So good morning, good afternoon, good evening, wherever you are in the world. For me, it's very early in the morning. Anyone who knows me knows I'm not a morning person, and here I am at 7 a.m. So apologies if I'm constantly reaching for the coffee as we do this session. So welcome to this Higher Ed Tech Student Series. This session is all about connecting anything to the cloud with IoT. Now, I will start with our standard code of conduct. You can read it all here. You may have seen this if you come to events before, but be nice or you're out. I think that's fairly standard code of conduct that everybody has these days. Be kind, and then you can be a part of all this. Now, I will ask everybody if they could check in. Go to aka.ms/reactor check-in and use the event ID 13369. This allows you to get copies of all the links that we're going to share with you today, and it also allows you to enter to get a voucher code for certifications. If you attend a certain number of these events and check in at these events, you can get a voucher for some Microsoft certifications, which are fantastic for your resume. Having that industry recognized cert is a really good thing. So by way of introduction, I'm Jim Bennett. I'm an IoT and academic advocate, which means I help folks who are involved in education be successful with Microsoft technologies, particularly around IoT. I'm based in Redmond in Washington in the US, hence why it's very early in the morning for me. You can find me all over the internet at Jim Bob Bennett on GitHub, Twitter, LinkedIn, Instagram. Feel free to reach out and connect. Any questions you have about the stuff we're talking about today, or using IoT in the classroom or learning IoT, please get in touch. I'm here to help you be successful with all these technologies. Now, if you remember nothing from today, if you only remember one thing and forget everything else from today, remember this one link, aka.ms/connect anything. If you follow this link, it'll take you to this web page here, and that contains all the links to the stuff we're going to be looking at today. So there's links to code, links to online learning paths, links to some of the stuff we're showing off, links to products, links to ways you can follow me on the internet. It's all here. So follow that one link and you'll be able to be able to find everything that we're talking about. So if you forget everything, if your brain tunes out, it's all here in this one place. Now, the topic of this conversation is all about connect anything to the cloud. And the fact is, anything these days can be connected to the cloud. If you look across the adverts on social media, you will see so many new consumer devices that are advertised as the internet connected something, like the internet connected toilet cleaner as one particular example that I see a lot. Anything can be connected to the cloud. And more things are doing this. It's getting harder and harder to buy a dumb item. Everything's smart, everything is cloud connected. And just to do a little demo of something that is cloud connected, I have got some cloud connected lights in my house. So I'm just gonna show you these lights. These lights here, you'll see I've got some green lights here and some Lego with lights on, all here. And these are actually connected to the cloud. So if you wanted to, you could control my lights. So if you head to aka.ms/control Jim's lights, you can actually take over control of my lights. So these are internet connected lights. If I go here and I click, say, the red button on this page, in a second, it'll go red. If I click the blue button, it'll go blue. Rainbow button, kind of go rainbow color. Apologies for the lights hanging down. I've had a bit of a technical failure. Some of my soldering is not doing so well, so that's why the lights at the top are not there. But you can actually do this. If you want to go onto this website, if you want to follow this link, right now you could play with my lights. And so this is kind of an example of some of the things you can get that are available over the internet and control. Having lights in your house that are controlled by it, having so many other devices that are controlled by the internet. So feel free throughout the session, follow that link and have a play with my lights. Hopefully we'll get that link just dropped in the chat in a second. Now these lights, obviously I have these lights in my house that I can control. I have so many other things in my house that I can control over the internet. I mean, I'm not big into home automation. I've only just recently bought my own house. Before that I've been renting, so I haven't had really much control over what could be automated. But just in the house that I've bought, oh, someone's turned my lights off, thank you very much. Just in the house that I've bought, I've got a fridge, a garage door, voice assistant, lights, security cameras, plugs, TVs, oven, doorbell speakers, a row machine, solar panels, and a thermostat, all connected to the internet. And this is just without me even really trying. Some of these are really useful, things like controlling plugs or seeing how much power my solar panels are generating is useful. My fridge, not so useful. It just lets me know when it needs a new water filter. My garage door, almost useful. I can ask my voice assistant to close my garage door. I can't ask my voice assistant to open my garage door. So some are useful, some are not useful. But as I say, this is me not really trying very hard. Because literally these days, as a consumer, you can buy millions of different devices that are internet connected, from vacuum cleaners to mattresses to outdoor sprinklers to toothbrushes to water fountains for cats. Everything these days seems to be internet connected, and there's some of that has some great advantages. Being able to ask your voice assistant to run you a bath is a fantastic thing. To have a Bluetooth connected toothbrush complain at you because it needs a firmware update before you can brush your teeth, maybe not such a good thing. But there's a lot of good stuff that is out there connected to the internet. And this is just in the consumer space. As you move into the healthcare space, industrial, retail, there's so many great things you can do by connecting devices to the cloud. Now, of course, this begs the question of how. How do you connect things to the internet? What's the kind of underlying technologies that you use to connect a thing to the internet? Very specific about those words because you've probably heard of the Internet of Things, IoT, the Internet of Things. Now, IoT is a term that's been around since 1999, I believe it was, and it's all about having things that originally would communicate just with each other. Now they communicate with the internet. They gather data, they share data, and they respond to requests from the cloud. So the Internet of Things is all about connecting things to the cloud and doing stuff with the cloud with those things. So to give a kind of a breakdown of what we mean when we say Internet of Things, really we mean two things. Internet of Things is made up of two fundamental pieces. You can probably guess what they are. It's in the name. There's the internet side of things and there is the things. The internet part is all about providing cloud services or connectivity to add intelligence. The thing is all about interacting with the physical world. So your thing, your device, it has sensors that gather data from the physical world. It'll then send that sensor data to cloud services that would use that data plus other data to make decisions. Those decisions will then get sent to the same thing or another thing, and that thing then would use actuators, which are devices that interact with the world, to do interactions. So your thing measures the level of light in your house. It sends a message to the internet. The internet says, yep, okay, you're a bit dark. It sends a message back to your thing and turns the lights on. Things like that. So it's your thing has the physical interaction with the real world. It understands the real world through gathering data from sensors, interacts with the real world through actuators, and the internet brings this level of control. But also fundamentally, really, it comes down to data. IoT is big on data. Your thing is gathering data. In the cloud side of things, on the internet side of things, you are working with that data to make decisions, and then the thing does the output of data. So IoT as a discipline, yes, it involves things, it involves working with devices and hardware. It involves the cloud, it involves cloud services, but it also involves understanding of data. There's no point in gathering data from your thing if you don't know what that data means or don't know how you should respond to that data. So when you're building your thing, you should understand what data what data it is that the sensor is gathering and how to process that. Even simple things like, is my temperature sensor measuring in Celsius or Fahrenheit? Or this number that I'm getting from the sensor, what does it mean? So understanding that data. So IoT, even if you're interested in being, like, for example, a data scientist, IoT is good to understand because these things can generate a ridiculous amount of data. And you need people like data scientists to process that data and understand it. So kind of data is very fundamental to everything we do with IoT. We gather data, we analyze it, we make decisions based off that. Now, just to put it in a real world example, one I've got in my house at the moment, which I was playing with a lot yesterday because it got very hot and I've been trying to get my air conditioning working properly. Let's think about a smart thermostat. This is kind of the canonical example of an IoT device. It's something a lot of folks are starting to get in their homes. Here's a kind of an overview of a smart thermostat. You have kind of the core device, the controller behind the thermostat. You have some kind of dial or keypad or something to set the temperature you want. You have sensors in your house to gather temperature data. You have connection to a heating, cooling, HVAC as they call it here in the US, type system to generate heat or air conditioning. You have a cloud connectivity. You have a mobile app to control it, and then you have other data from things like your calendar or from things like weather data. Now, the way this would work is you would start by giving data to your thing. Your thing would have sensors to gather data. One sensor would be a dial or an input device where it would sense a value that you have set. So you go to your thermostat and say, I want my house at 20 degrees. That's Celsius for any Americans watching. I want my house at 20 degrees Celsius. Your thermostats around your house would gather data around what temperature your house is, various parts in your house. And all that data, all that sensor data would feed into your thermostat. That data would then go up to the cloud. Your thermostat will say to the cloud, hey, this person wants a house at 20 degrees, and I've got 4 sensors, and I'm reading 19, 18, 20, and 17, for example. The data will go up to the cloud for decisions to be made. The cloud will then take data from other places. It would also look at what data has come from the mobile app. Maybe you've actually said, you know what, I want 18 degrees in the mobile app. It'll also look at things like weather data, time of day, and your calendar to help make some decisions. So, for example, if the cloud knows that you're on vacation, but you've set your house to be at 20 degrees, it knows not to bother. Why waste electricity heating up your house to 20 degrees if you're on vacation? Of course, look at weather data. If it's about to be a really scorching hot day, maybe you don't want to heat the house up because just the natural heat of the day would heat the house up. So the cloud can make these smart decisions based on a wide range of data. Once it's made those decisions, the decision then gets sent back to the thermostat to say, this is what you need to do with the heating and cooling system. And then that works with the actuator, the switches, the controls, the mechanisms by which you can control your heating system and cooling system. And that then connects that tells your house what to do, tells it how to respond. So that's the kind of canonical example. Let's actually have a look at a demo of one of those. Let's actually look at a heating system. So I'm just going to zip over here and get something running because I can and start gathering some data. So I have got my own little portable IoT heating system. Not quite as fancy as the highly expensive thermostat and heating and cooling system that I've got built into my house, but I've got one here. So I've got a thing here, a device. This is a Raspberry Pi. I'll talk about those a bit more in a second. I've got a temperature sensor here. So this little device here, this is a combined temperature and humidity sensor. So it gathers temperature data, gathers humidity data, and I can then use that data to make decisions. And I've got a relay here. A relay is an electromechanical switch. So I can send a signal to it to say, turn on, turn off. And that's connected to my highly advanced air conditioning system. A fan, a simple fan connected to a battery pack. And this is my heating and cooling setup. Now this is running. It's currently detecting a temperature of 25 degrees in my house, 24, 25 degrees. So it's a little bit warm here today. And I'm going to go to an internet service. You'll see here my internet service here. I'll talk about this again in a bit in more detail later, but it's showing me a graph of my temperature. My maximum temperature is 25 degrees. I'm going to bring my temperature down. Let's go for, say, 20 degrees. Let's set it to 20. And then what should happen? There we go. My fan's on. Lovely bit of cool air coming through. But, you know, actually, that's fine. Let's go for max temperature of 25 degrees. Set it in there. In a second, my fan will go off. So you see here, don't know if you can see in the output here, it says turn fan on, turn fan off. So the cloud is controlling this. The data is being gathered from my sensor, is going up to the cloud, and that is then controlling this particular device. And it's set to 25, and again, it's taking data from the temperature sensor. So if I can put my hand on this temperature sensor, generate some warmth. Come on, warm up. Takes a few seconds for it to warm, but as it will warm up, the fan should then kick in as well. Come on. Come on. There we go. So it's warmed up and the fan's kicked in. So that's my basic temperature sensor. Let's just turn the fan off because the noise is annoying. So that is a home-built temperature sensor. That's using IoT. I've got temperature sensor, gathers data, sends it to device, goes up to the cloud. Just have one question in the chat. How does using IoT devices affect internet security? We'll get to that later. It's a very important topic. Yes. The S in IoT stands for security. Is the old joke, because there is no S in IoT. Great question. Thank you very much. We will get to that later. So let's talk about things. There is a million different types of thing you can use. But as a developer, as somebody who wants to play with this technology, to me, things kind of fall into two large buckets. You have single board computers and you have microcontrollers. Those kind of the two different buckets things come in. Now, in terms of single board computers, to me, the best ones on the planet are the Raspberry Pis. Okay, Raspberry Pi is an absolutely phenomenal technology company. It's based in Cambridge in the UK. It started out as a charity to help kids learn to code, and they wanted to build relatively low-priced devices that you could use. You could literally plug it into your TV, plug in a keyboard and mouse, and learn how to code. And on top of that, these devices have pins to connect other hardware, which makes them great for doing Internet of Things work. So to show off a couple of Raspberry Pis, let's sit back over to my camera. So here's a Raspberry Pi under here, but you can't see it very well. So let me bring one closer. Here is a Raspberry Pi 4. So this is a single board computer, and that means this is a fully featured computer. It runs Linux. It's got a quad core 1-point-something gigahertz processor. This one's got 4 gigs of RAM on it. It's got 2 HDMI ports, little miniature HDMI ports there, capable of 4K resolution, Ethernet, USB. It's got a dedicated camera socket for a Raspberry Pi camera. And these pins here, these are called GPIO, general purpose input-output pins. And this is where you can connect devices to we can connect IoT devices to your Raspberry Pi and access them. So on my fan here, I've got a Raspberry Pi. You can see it here. And this has got what's called a Grove Sense app. So it's a company called Seed Studios. They make great stuff for the Pi. You slide this hat on, it gives you standard plugs, and you can plug in temperature sensors and other bits and pieces. Or you could just literally take cables from the GPIO pins, connect them to LEDs and other components if you want to, or you can buy a whole range of different bits and pieces that you can connect on there. I've got a few other cool things I'll be showing off on Raspberry Pi later. But they're fully featured computers, and you can connect a whole load of good IoT devices to them. Because they're fully featured, you can program them in any language that is supported on Linux. So you can program them in Python or C++ or C# or F# or Go or Java or JavaScript. You name it, you can program them. Now this Raspberry Pi here, this Pi 4, starts at about, I think it's about $35 US for one of these. If you want to go even cheaper, they have the Pi Zero, $5 without Wi-Fi, $10 with Wi-Fi. Teeny tiny little computer, but this is a fully featured Linux computer. So I've got it here, and just to show you that it's a fully featured Linux computer, here it is running Chromium browser, available through VNC. Not particularly fast because it's a $10 computer, but it runs a full Linux operating system. I can connect via SSH, if I want to just log in remotely, or I can actually run a whole UI. I can plug that $10 computer into keyboard, monitor, and mouse and code up on that device, which is pretty cool. Now, Raspberry Pis, I absolutely love them. I could literally do an hour just on how amazing Raspberry Pis are. I will actually show you one more thing because I love Pi so much. They've even got an all-in-one computer. So here's a Raspberry Pi. It's built into the keyboard. You plug in the mouse. You've got GPIO pins in the back. I've got lights on mine, and you've got a fully featured computer. So you don't even need a keyboard and mouse. It's like you buy that kit, plug in a monitor, and away you go. I love Raspberry Pis. They're so cool. That's really kind of the winner in the single board computer stakes. There's other single board computers. To me, the Raspberry Pi is the best one for IoT developers to get started with. Now, have I ever set a home server using Raspberry Pi before? Yes, I mean, a Pi is a computer, so you can set it up to do all manner of different things. I've got one running as an ad blocker connected to my router. They're just relatively cheap computers. So if you want to set up a server to do home automation or store your movies or anything like that, the Pi is perfect for that because they're, the benefit of them is they are literally $35. You can't get a computer at that price range that's not a Raspberry Pi. So that's the big benefit. It's powerful enough. I could run my coding. You can run VS Code, the #1 developer text editor, on a Raspberry Pi. I could literally do most of my day job on a Raspberry Pi. They're that powerful. Okay. Ugh. There we go. So the other side of the fence, as well as single board computers, you've got microcontrollers. Now, microcontroller is not a fully featured computer. It is a chip that runs the code you write. Some of them don't have operating systems. Some of them do, but the operating system is like really, really thin, tiny, manages the networking stack, things like that. It's not really designed that you can plug in a keyboard, monitor, and mouse and use it as a general purpose computer. So microcontrollers are all about just running the code you write. They are usually much cheaper. I think the cheapest one is only a few cents. They are smaller. You can get them small enough to fit in the dimple of a golf ball. They are slower. You don't get a quad core 1.something gigahertz processor. You get like a few hundred megahertz processor. They have a few kilobytes of RAM because they're designed just to run one job very, very, very. Now, you typically program them in C++, but you can use things like MicroPython, which is a variant of Python designed for small devices, or CircuitPython, similar idea. Now, there's a number of different ecosystems for these microcontrollers, which contain core libraries and ways to interact with them. Arduino is probably the most famous. They're fantastic. You can get a whole host of Arduino compatible boards, and the Arduino libraries have got access to do pretty much anything. So to show you some kind of Arduino devices, what have we got here? We have got, so this is one here. This is called a Wio terminal, made by Seed, the people who make this ecosystem here. It's got a screen, buttons, $30 for this, with the screen, the buttons, microcontrollers hidden in there. It's got Wi-Fi, GPIO pins on the back to add hardware. It's got these little sockets here, which are the same as the sockets on my Pi to plug in devices, light sensor, accelerometer, all manner of stuff, all built into a little board. That's like $30. It's kind of the top of the range microcontroller. But then you get smaller. This is the standard ESP32 microcontroller. I think it's got like 256 kilobytes of RAM on there. It's not very much. Wi-Fi. These are like $5, $10 a development board. Another one here. This is $6, I think, for this one. It doesn't have Wi-Fi. It's got Bluetooth, LEDs, accelerometers, light sensors, microphones. So you get a whole range of these different boards as a developer board with a whole lot of different sensors on board, or you can literally get, if you wanted to, just the teeny tiny little chip, and then you can mount that on the board that you wanted. So microcontrollers, they're lower level. They're all about connecting. You'd program in C++, you just run the code that you want. They boot up really quickly, and they're the kind of thing that would go in most commercial devices. So if you're buying an IoT device, a lot of them would have a microcontroller in there because they're substantially cheaper than the single board computers. So that's kind of the thing side as a developer. So you've got your thing. How would you then connect your thing to the internet? Now, these things, obviously, a lot of them have got Wi-Fi in them. They can connect to the internet. They could just call a web service, a web API, as if you were connecting to the internet in any normal way, shape, or form. You can have any kind of web API that you could call. But that's not normally how they work, partly because that's not particularly secure. So the way a lot of internet devices will work is using some form of cloud IoT service that's dedicated to IoT. And a lot of these have security built in. So to go back to the question earlier about internet security, you need to make sure that when you connect to the cloud, only the devices that you want can connect, that nothing can get in the way and intercept the data or change the data, and nothing can get in the way of the data coming back down to your device. And a lot of internet IoT services provide those capabilities for you. So they will have secure access. So only a device that's either got a certificate installed or has got a magic key in the connectivity can connect. It'll make a secure connection to the internet. It'll send messages using usually a well-established secure messaging protocol. So a way of sending messages back and forward, one that's well-established, well and secure. And then on the server side, it'll make sure that only devices it knows about are connected. It'll only send messages to devices that it knows about. And you can even bring in more advanced security built into these IoT services. For example, if you're running Windows, you probably use Microsoft Defender as your antivirus and anti-malware software. It's coming on the Mac as well. It's also available on IoT devices. You can literally turn on Microsoft Defender for IoT devices and that will make sure that malicious payloads are not being sent. Like kind of understand what data you should be sending and receiving, and make sure only devices that can connect do connect. Now, the IoT services, they start with the very basic pipe of you connect your device securely, messages come from the device, you send messages to the device, and then something else has to sit there on the other side of the pipe to process your data. Or you can have a full software as a service platform that does everything for you. You kind of have this choice of both depending on what your needs are. Now, on the Microsoft space, I work for Microsoft, so obviously I'm going to talk about the Microsoft toys. If you want the basic IoT service that provides the big fat pipe, IoT Hub is what you want to use. So this is it's a pipe. You connect authorized devices to it, only authorized devices, nothing else. You send messages to IoT Hub, and then IoT Hub will then send those messages on to another service that does something. It doesn't do anything with the messages themselves. It just literally acts as a relay. So the message comes in, and then you have another service that listens on the other side. And then when your cloud service wants to send a message back down to your device, the cloud service will then send that message to the hub, and the hub will direct that to the device. So quick demo of IoT Hub. I'll show you IoT Hub in the cloud. Here it is. There's nothing really interesting to see here. This is my IoT Hub configuration. I can see the number of messages going back and forward. I can see devices connected, but I can't really do anything with this data from here. Now, in terms of security, I have to define my IoT devices. I either define them up front in here, or I can give the device a special key and say, allow devices with this key to connect and register as a new device, which is kind of great for a consumer perspective. This is my security. I have my keys here. Without these magic keys, for this device wouldn't connect. So in terms of getting it connected, I'm just going to dig through some cables and plug in a device. And I'm going to plug in this one here. This is my ESP32. Plug this in. That's now connected to IoT Hub. So I'm going to go to, don't need that window anymore. I'm going to go to here and click my serial monitor and show you the output from it. Now I'm using VS Code. VS Code is my preferred coding environment for anything IoT. Now you can use it for single board computers, remotely connecting, or you can use it for microcontrollers. There's an extension called Platform IO, which I love using, that can code up all manner of different microcontrollers. If you're just sticking with the Arduino ecosystem, there's an Arduino extension that allows you to code Arduino devices from inside VS Code. So I can write my C++ code, deploy it to my device. Right now, I've got some code here that uses a Hall sensor built into my microcontroller to gather magnetic data, and then I'm sending this up to the cloud. So you'll see some numbers are coming out here, sending telemetry Hall 4, -1, messages going up to the cloud. Now, if I go to IoT Hub here, I can't really do anything with this data. IoT Hub is just the pipe. Messages are coming in. That's it. Yeah, it's 24,000 whatever messages say. Messages coming in, that's it. It's not much you can do with it. So instead, I need to connect something on the other side to read the data. Now, I can actually do that. There's an extension in VS Code that allows me to monitor the messages coming in. So if I actually turn this on in a second, come on. Come on. Oh, there we go. It's coming through. So you'll see message sends a Hall reading of 8, 8 to 5. So this is just connected to the other side of the hub listening for messages. What you would do is you would write your application to sit on the other side, gather data, and make decisions. So this Hall sensor is a magnetic sensor. So if I put a magnet on top, see the number goes up, 12, and then, yeah, let's take the magnet off. And it drops. So it literally is a magnet. I'm just literally sitting a magnet, on top of this thing. And that sends data, sends this magnetic reading up to the cloud, and I can process. I've got something here I'm just listening on the other side from a monitor tool, but I would build an application that would listen to this data. Now, in terms of sending messages back to the device, I can do that from IoT Hub as like a little playground to test my device out. But again, you would write code that will send messages back to your device. So if I send a message, not that one, I want to send a method request to my device. I'll do LED on, and I send that to my device. We should see here that blue LED is now on. If I go back, go LED, LED off, send that. You see my LED's gone off. So normally you'd write your application to do that. So you have some kind of application code, sits on IoT Hub, reads this data that's coming in, and then responds to that. Now this magnetic thing, this is a basic security sensor. You think if you've got a security sensor in your house, you may have something on your door and something on the door frame, and as the door closes, it uses a magnet to measure the Hall effect, exactly the same as I'm doing here with my IoT device. With my IoT device, the magnet. So as my door closes, the magnet will come into place, and it can start reading that. So you'd have your security system in the cloud, reads that your door's open or closed. So that's IoT Hub. It's not that interesting to look at, incredibly powerful, not that interesting to look at. Now, IoT Central, on the other hand, is our software as a service platform. This is the whole application that we've built that allows you to get going really quickly doing things with your data. Obviously, where it's a software as a service platform, you're limited by the capabilities of the software. So you can't do everything with it, but what you can do, you do quickly. So if you want to see charts and graphs and control devices really quickly, IoT Central is the way to do it. If you want to build very more advanced systems, you would then use IoT Hub for those ones. So IoT Central, best thing to do is just show it. Let me show it. So you saw it earlier when I had my fan set up, but let's show it with, what should we show it with? Let's show it with a car. Let's show it with a car. I have a car. Let me just turn my camera around. I don't know if you can see, I'm running out of cables here. I don't know if you can see down here. Point it out of my foot. That is my little car. This is a car. It's a car based around a Raspberry Pi. So there's a Raspberry Pi 4 in there. It's connected to a camera, wheels, and I can control that. And I've written an IoT Central application, here it is here, to control my car. So I can, if I can go here and click on my car, let's drive my car forward. It lost its connection to the car. So what I'm doing here while this is connecting, I'll explain this. Visual Studio Code, the world's favorite developer text editor, can allow you to remotely connect to a device like a Raspberry Pi. So, your battery's not flat. Let's retry that. So I'm actually running VS Code, and I'll make a remote connection to the Raspberry Pi. Right, let me just turn it off and on again. We'll try that in a second. So VS Code makes a remote connection to Raspberry Pi. It allows me to, it will literally give me an Explorer that allows me to browse files on the Pi as if I was running on the Pi itself. It allows me to run a terminal that runs on the Pi, and I code, I debug, I do everything on my Mac as if I was doing it on the Pi itself, which is pretty powerful. It allows me to be remotely connected and just code as normal. I just happen to be coding against the Pi. At least I would do. The blimmin' thing would connect. Okay, let's give that one more. Okay, while it's doing that, let's talk through IoT Central. So IoT Central is designed so that you can easily build an IoT application. So when you launch it, when you run it, you create an application. What do you mean? Try one more time. You create an application and say, yeah, I want to have an application like my car, for example. You then define what's called device template. So you say, this is the data that my car is going to send me. In this case, how many times it moves forward and backwards and capture images, and then the data, the messages I want to send to my device to control it, such as move forward, move backwards, kind of commands for it. And you can define views. So I want this view that happens to have capture an image from the camera that's saved into storage. I want to have a view that's got the different counts of things. So you can define how your application looks. You can define the devices. When you define device, each device has some secure key information, so that only the devices that you define here can connect. And then for each device, you can kind of look at the data. So all this entire application, this entire website you see, I didn't write any code at all for this. I literally click, drag to build up this whole application. And it does not. Let's try that again. I don't know why it doesn't want to connect. One last try, and then we'll give up on this car. Okay. So the way the car works is it uploads an image to blob storage. So rather than use the IoT service for the image that it's capturing, instead it just saves it into blob storage. And then this website will actually show that in the IoT Central app. Now, I don't know what's going on. It's working absolutely fine this morning, as you can tell by the monkey picture that it captured from those monkeys there. But for some reason, doesn't want to connect. Oh well, we'll skip that down. Okay, but the idea with IoT Central is it allows me to quickly build this kind of application. I built this entire application in about 10 minutes. Obviously, I know what I'm doing, so I've done it before, so it's faster for me. But this, you can very quickly throw together an application to get going with your IoT device. You can do things like rules. If you think about the fan I had earlier, I was setting a temperature for my fan. I have a rule that says if the temperature goes below the maximum temperature, turn the fan off. I can do analytics. I can set up jobs. I can export my data. There's kind of a lot of things I can do with IoT Central just through a UI. Okay, so we talked about IoT devices. We've talked about dev kits, about Raspberry Pis and microcontrollers, and we've shown how to gather data and send it up to the cloud via IoT services. Now, excuse me. One problem we have with IoT services is that data. There is a lot of it, a lot of data. These devices can capture sensor data every second, send it to the cloud. If you're doing any kind of video-based data, if you've got an IoT device with a camera, you could stream live video to the cloud. It is a lot of data. Now, analyzing that data in the cloud can be very expensive. It can also just eat your bandwidth. You know, there is a limit as to how much data you can send to the cloud. For example, if you've got a factory with 1 million different sensors gathering a whole lot of data that it needs to make a decision on how safe your environment is. You know, if it detects that your machine is running too hot, it needs to be able to turn that machine off instantly. And you can't get that data to the cloud fast enough because somebody is watching Netflix in the break room, you have a big problem. So rather than rely on bandwidth, rather than what happens if the internet goes down and all those kind of considerations, what you can do is you can actually run IoT analytics on what we call the edge. So you use your cloud to build up AI models or data analytics applications or anything like that. You build these complicated algorithms to analyze the data you're getting from your IoT device. And then instead of doing it in the cloud, instead of shipping your data up to the cloud to do it, you instead ship your workload, your AI model or your data analytics application to an IoT device, and you run that on the IoT device. So you're not doing stuff in the cloud. Classic example would be you have a security camera set up, or multiple security cameras, they're capturing high def video data, and you want to do analytics on that to look for people who shouldn't be there, or people not wearing hard hats in a hard hat zone, or cars arriving at a depot, anything like that. To stream HD video up to the cloud uses a lot of bandwidth and uses very expensive computers in the cloud to analyze it. Or you have the analytics for that running locally on an IoT device on the edge. So first type of IoT solutions is what we call IoT Edge. So this is all about building big, complicated workloads and running them on powerful computers on the edge. So you would do live video analytics, for example, on a GPU-powered machine that runs on the edge, on site, wherever your data is coming from. So let's do a little demo. Let's go back to my camera and wobble my camera around and show you this little box of tricks here. This is an NVIDIA Jetson Nano. In fact, the Jetson Nano is just a little tiny board inside there, sitting on a carrier board with a fan to keep it cool and all that. NVIDIA, you may know them from making the graphics cards that power games. They also make AI accelerator boards. It turns out that the same math that you use for doing fantastic graphics on your Xbox or your PlayStation is the same as the mathematics you need to do AI workloads. So to do AI analytics, to run AI models, you can get the same amount of acceleration on those as you would with the same hardware that you would do to get accelerated 3D graphics. So NVIDIA makes 3D graphics card, also make AI accelerators. And this Jetson is actually it's a single board computer, just like the Raspberry Pi. It's about $100 for one of those, so it's not that expensive for what it is. And I can run AI workloads on here. So this is actually connected to my IoT Hub. Come on. There we go. It's connected to my IoT Hub, and I've got a YOLO model, which is an image identification model, running on there. So it's YOLO. I configure it from the cloud. I say run this YOLO model, and it pushes that YOLO model down to my Jetson Nano and runs it. Now I could then use the cloud to build new models. One click here, it pushes the new model down to the device. So it's managed like an IoT device. The data is sent like an IoT device. This would run on the same network as my IoT devices, so I'm not shipping data to the cloud. And this particular one, I've got it connected to a YouTube video, and it's doing live video analytics on a YouTube video. I could have easily set it up on a webcam and done live video analytics out my window, but I thought the YouTube video might be more fun. So here it is here. It's currently running at 8 frames a second, analyzing this was one of the developer keynotes from Microsoft Build last week. And so it's sitting there, you see it's detecting person. Oh, it thinks that bag there is a person, but it's doing it at 8 frames a second. So it's doing that kind of live video analytics, 8 frames a second on a $100 device. So it's detecting bottles. It's pretty good. If I was doing this in the cloud, I would have to stream this data in high def up to the cloud. And then the kind of machines you get in the cloud are ridiculously powerful. They're way more power than I need to do this analytics. So I'll be paying the cost of this device every month to rent in the cloud. And then I would have to rely on the internet being there. If the internet goes down, I can't connect. So this is a great way to get analytics running on the edge. This is running, say, on that device. And then I could stream data. So I could capture IoT data such as how many people it is detected in the image stream and ship this up to IoT Hub for analytics later. So just go to some questions. Can IoT Central be used to share the same IoT device across multiple applications? No, because each IoT Central application has a unique set of IDs. So one device would then send data, will make one connection to IoT Central and send one thing. Now, there's nothing stopping you having multiple IoT Central applications running on your device. So a device could create multiple connections to different IoT Central applications. That's absolutely fine. I've done that many, many times just to save on devices. But it's one application doesn't normally feed multiple. Instead, you can put things like gateways and other devices in there to feed multiple data up to the cloud. What disadvantage are there of migrating application data from the cloud to the IoT device? The disadvantage is scale. You can't scale. If my Jetson Nano is not powerful enough, I can't just, we have 2 or 3 clicks, get another Jetson Nano. I have to physically install one. If the Jetson Nano fails, I've got to go and physically replace it. Whereas up in the cloud, I've got all the backups, I've got all the management for me. So I lose the management, but I save money and my data's closer and my data's more private. So if I was doing, say, hospital data on here, it stays away from the cloud, which makes it, which allows you to adhere to various privacy regulations. So yeah, it's kind of swings and roundabouts as to what you want. Privacy, speed, not relying on the internet, you want it on the edge. If you need that security of the device is always going to be there, you can do it in the cloud. Recording after, yes, this should be recorded. Details should be coming out at some point. I think the same link as this as to where you can get to the recording. Okay, so the other thing in terms of IoT on the edge is this is running on a Jetson Nano. This is kind of quite a powerful device. You can also do what's called TinyML. I will refer to this picture here of Benjamin Carbe, a colleague of mine at Microsoft, who has built an artificial nose. His nose is getting very famous at the moment, and his nose can sniff out the difference between a number of different things. Yes, he is French, hence why he went for the baguette and the stereotypical beret and striped shirt for this particular picture. But he originally built this to sniff out the differences between different alcoholic spirits, whiskey, vodka, etc. But it's kind of working for multiple different devices. And the idea of TinyML is instead of running it on a powerful computer powered by a GPU like a Jetson Nano, you run it on a microcontroller. It builds machine learning models that are tiny. We are talking a few kilobytes in size compared to the megabytes or gigabytes of a large model. The YOLO model that's running on my Jetson Nano is like multiple gigabytes, I think, to download that model. This model that he's running here for identifying different bits of different spirits or baguettes or what have you based off their smell is running on a microcontroller. It's like 20K. TinyML is great because not just the models are really small, but where they're on microcontrollers, they are very low power. If you wanted to build, say, a smart tag to be fitted to an animal's collar to track the noises elephants are making for conservation work, you can't put a Jetson Nano plugged into mains power on that collar. You need something that can run on batteries. And TinyML allows you to take a microcontroller and run AI models on that microcontroller. Now, these microcontrollers, they're low power. You can run a microcontroller on a battery for weeks, months, years. They take hardly any power at all. So imagine being able to run an AI model continuously on a battery. And that's kind of what TinyML gives you as a capability. So just to show you, where are we? I've got some TinyML code here. This is a TinyML model that I've got built. I think the entire thing is about 15 kilobytes. It's not particularly large. And I've got it running on, where's my camera? I've got it running on this. So this is a little microcontroller. It's an Arduino Nano. It's got an accelerometer on it. It's got a microphone. And it's got, 256 kilobytes of RAM in it. It's not much more than the ZX Spectrum that I first started programming on back in the 80s. It's small, it can run for a few years on just a standard coin cell battery, and I've got an AI model running on this. So just to prove it, what I'm going to do is go here, I'll bring up my, let's close this one down actually, and close you. So I've bring up my serial port, so connect. So it's now saying my device is still. I'm not doing anything. So what I'm going to do is I'm going to shake it. This is my device here. Pick up the device. And I'm going to shake it because this is how I get fit in the mornings, is by shaking IoT devices. And look, it's predicted that I'm shaking my device. And now if I wobble it from side to side, I'm going to put it down here. Let's wobble it from side to side. Look, wobbling from side to side. Give it a few seconds. And in a minute, should, come on, side to side, side to side. There we go. So that is an AI model running on the microcontroller. It's exported as a whole load of C++ code. It's a TensorFlow Lite model. TensorFlow is like one of a very famous set of tools for building and managing AI models. It's this thing called TensorFlow Lite, where you take a big model and you literally strip it down as small as possible. You convert the large numbers that are in the model to smaller numbers. You strip out as much as you can and optimize your model, and it runs in a few kilobytes of RAM. And so this is only 256 kilobytes of RAM on that board, and it can run this perfectly happy, and I say I can plug this into a coin cell and I can run this for years on a coin cell battery. So it gives me a chance to actually do machine learning on a much smaller device, which is pretty cool. So again, I can run this closer to my data. This is great for areas where I have no connectivity, like collars on animals, for fitness trackers. If you've got a Fitbit or an Apple Watch, it's essentially running something like this to analyze that data on your wrist rather than sent to the cloud. And you can't have your watch continuously plugged into the mains power. So that's TinyML, a way to run stuff on the edge. Now, this is all about the Internet of Things. We've been talking about the Internet of Things. Very first word there, Internet of Things. And I'm going to say this, do not connect anything to the Internet, ever, at least without thinking about it first. So going back to the question about security, you should always start with the default point of view of not connecting anything to the Internet until you know what you're doing, because it is a minefield of things that can go horribly, horribly, horribly wrong. So this is where things might get a little bit uncomfortable as you realize just some of the risks of some of the devices you've got that are already connected to the Internet. Okay, so first of all, privacy. This is hugely important. If you're going to build an IoT device, you have to consider the privacy of the data that you're gathering. And not just the privacy of the data and how you're storing it, but of the access people can have to that. For example, Kayla, a doll designed for kids. You give it to your kid, you can talk to your kid, you can record messages for Kayla to say to your kid, and these were not secured in the cloud. So anybody could go and download the private messages that you've sent to your child or the messages that your child has sent to you. You don't want that. You need to make sure the data is secure. And that's just the data that was captured from the device. Baby monitor, the Freddy baby monitor. Somebody got really confused by the fact that baby monitor kept pointing in different directions, and they actually watched it move. Someone had hacked into it. And by hacked, I don't mean nefarious people have spent years trying to crack encryption. It was just unsecured on the Internet, and they were able to connect to it, watch people on baby monitors. There's been accounts of people actually talking to kids in the middle of the night on baby monitors. Even worse, when you have people involved, people can be not very nice. There's a very big security company all around the world. And in the US, somebody here managed to get access to people's accounts. He was literally installing it. And if he thought the person he was installing it for was an attractive person, he was ensuring he had access. So he was able to watch people, to spy on women in their homes. Very, very creepy. So there's a whole lot of privacy implications with having these devices. You may think, yeah, it doesn't matter how many times people know how often I clean my toilet, but devices got cameras in them, device got microphones in them, so people can do these things. You need to keep the data private, and you need to keep the device private. You can also get access to things. You can use IoT devices to get access to other things. Printers. It's very easy, as it turns out, to download the last printed document off a printer. You want to access some secure corporate information? Connect to a printer over Wi-Fi and download the last document printed. Coffee machines. You stick your bank card in a coffee machine. There have been smart coffee machines, internet-connected ones. They've managed to attack them and download credit card details from a coffee machine. One of my favourite ones as well, a fish tank thermometer had an open Wi-Fi access point on it to allow you to connect to it to configure it, and hackers used that to then break into a network the thermometer was connected to, which was the network of a casino, and they stole data from a casino through a smart fish tank thermometer. So having any form of connectivity allows access to your network, which is a bit scary. Yeah, this is disturbing and creepy. Yes, it is. This is stuff you have to be aware of, because a lot of people are throwing out these consumer IoT devices. So yeah, got to be connected, got to be connected, got to be connected. Not considering privacy, access, and security, and all these different implications. So if you're going to build one of these devices, think about this first. And also think about connectivity and app support. If you have a device that needs access to something, you have to consider what happens if that something is not available. Nike built some shoes that you tighten up using an app. This was on Android. An update was pushed out to the Android app that broke the Nike app. So suddenly, if your phone was updated, you couldn't tighten your shoes. Another one I love, Ferrari, a $200,000 Ferrari the update started when it was in the garage, but unfortunately there's no connectivity. Couldn't do the update, couldn't get in. Literally, they had to get somebody from Ferrari to travel thousands of miles to come and do an update on this Ferrari because it started the update while it was underground. It couldn't cope with the lack of connectivity. This is the Internet of Things, and we know the Internet is not reliable. Another one here, I can't vacuum because a cloud provider is down. If you've got a smart vacuum cleaner and the cloud provider goes down, you can't vacuum your house. You can't turn your lights off. You can't control your thermostat. The early versions, I think of one of the big famous thermostats would only work with internet connectivity. You lost your internet connection because of, I don't know, a huge snowstorm. You wouldn't then be able to turn your heating on to deal with the huge snowstorm. So again, you need to think about connectivity. Although it's the Internet of Things, what if you don't have internet? So I know it's a bit of a scary topic, but I think it's hugely, hugely important. Don't just connect things to the internet until you think about why. And if you do own any IoT devices, be a bit cautious about them. You know, go onto your favorite search engine and just search for IoT hacks, and you'll be disturbed by what's out there. There's some ridiculous ones. There's some not safe for work items that are hacked. It's very, very scary. So before you consider buying any kind of connected device, do a quick search, find out if it's been hacked or not. Okay, so after that horrific scare, how do you get started with IoT? So you've decided you want to connect something to the cloud, you understand safety, security, you're going to be smart about this. How do you get started? So a load of resources here for you. aka.ms/learn-AZIoT. That's a whole lot of hands-on IoT learning paths on Microsoft Learn, which is a free self-guided learning platform. You can go on there. You can, it's all free. You can spin up resource in the cloud for free. You don't even need an account if you don't want to. And you can get playing with IoT Hub, IoT Central, and the various IoT servers. Kind of learn how to use the Microsoft technologies. If you like this stuff, the AZ220 is our certification. Always looks great on your CV, aka.ms/AZIoT cert for all the details on that. I know if you register for this, and I think it's 4 of the sessions in this series, we've got vouchers for certs. So it's a good thing to have. It's great to build an IoT device. I will also say as well, Microsoft has a competition for students called the Imagine Cup, aka.ms/MS Imagine Cup. We've just wrapped up this year's competition at Microsoft Build. The winner walked away with $75,000. I believe, and a mentoring session with Satya Nadella, our CEO. They actually built an IoT device for monitoring babies in hospitals in Kenya to help improve the healthcare that was having reduced infant mortality. All done using an IoT device they can attach to kids to monitor kids' skins. AI on the edge, so AI running on IoT Edge devices, bit of IoT, and they want a big stack of cash. Some of the runners up, again, were also IoT devices. There was a smart ear tag for cows running the TinyML model on this device, on this ear tag. So IoT is, if you love IoT, build something that can change the world, enter the Microsoft Imagine Cup. Also, if you want to learn more, you want a much more deeper dive, I'm running an IoT for Beginners video series, aka.ms/Hello IoT series page. Head there, sign up. It's going to be 4 live streams interspersed with 4 sets of office hours where I will really get down deep. We'll literally spend like the first hour just talking about what is IoT, showing a few very, very basic demos. It's that kind of level. And then there'll be an hour the next day to dive in deep and just answer any questions that you've got. So we're going to give it a whirl. We can try 4 lessons and 4 office hours all throughout July. So head to this and sign up if you're interested. Saying about July, at Microsoft, July is JulyOT because it's the greatest pun ever. And JulyOT, we are focusing a whole month on IoT. So, ooh, sorry, there's me being really early. That's my alarm to wake me up in the morning going off in the background. So July is all about IoT. So if you go to julyot.com, you'll see last year's thing. Check back there in July. We've got a whole lot of great content all around IoT coming for you. We have got some fantastic stuff. So hashtag JulyOT on social media or julyot.com. Coming in July, a whole month of IoT goodness where you can learn more. And with that, thank you very much. Join the Reactor community. Follow MSFT Reactor on Twitter. YouTube video, all the Reactor, YouTube link where all the Reactor video is going to be. Get in touch with the meetup and join it. And yeah, thank you very much. We are at time, but if anybody does have any questions, I'm happy to stick around if we're able to do that. So if you've got questions, stick them in the chat, and I will do my best to answer. Let's see what there is. Some stuff here. Cool. I think I've answered all the questions that were there. So yeah, if you have any more, stick in the chat. Otherwise, thank you very much. Enjoy the rest of your day, morning, evening. And yeah, so follow all the links. I will just put up the, I'll put up the first link as well. Way too many slides. Come on, come on. There we go. So that's the link. Follow that if you want everything. How powerful can the tiny ML models be from your experience? That's a great question. It depends how you define powerful. Now, they're not, you can't do full live stream video analytics, for example. You can't do the, 8 frames a second I was getting on the Jetson Nano. You can't do that. You can do image analysis, but it's not ridiculously fast image analysis. It might take a few seconds to analyze one image rather than multiple frames per second, and it's not as accurate. You lose accuracy. Do you think these big models that are hundreds of megabytes in size, you're shrinking them down to kilobytes, you lose a lot of accuracy. I mean, you saw the speed. I don't know if you saw the speed when I was shaking the thing. It took a while before it picked up the shake, and when I was going side to side, it took a while before it picked that up. So you can't use it for, I need to know instantly and I need 100% accuracy. But if you're, say, measuring, trying to guess the motions that elephants are making, whether they're scraping off bark with their tusks based on the continuous repetitive movement, or noise they're making, whether they are in must, which is where male elephants get on heat and get quite aggressive, or whether they're hungry, or whether they're communicating, if you've got kind of a long period of sound, you can gather that kind of data. So they need a while to process. They're not very fast and they're not very accurate. So you can't use them to find really subtle differences. But that trade-off obviously is they run on a battery for years. If you need to monitor the noise an elephant are making over multiple years, then TinyML is the way to go to do it. You sacrifice accuracy, but you get multiple years worth of data. So it's just that it's the trade-off you have to make. But I mean, they can be. You can't identify 1,000 different things in an image. You could use them to distinguish between, say, 2 things, but not 1,000 things, not a million things. You can't run speech to text on them to actually transcribe audio, but you could do a wake word model. If you think about a home assistant like an Amazon Alexa or a Google Home, the wake word, when you say Alexa, picking up that wake word can run on TinyML, but then the actual processing of the speech that you say, that will then get sent to the cloud to do it. So you can kind of combine the two, the TinyML just for the single wake word, and then the power of the cloud for more advanced analytics. We should be careful with IoT hacks. From your own experience, what's the best way to defend against IoT hacks? Certainly limited to security, our device can be used to design physical security protection, like looking at a door. The best way to protect yourself against IoT hacks is don't connect anything to the internet. Literally, do not connect it. If you're running any kind of consumer device, you don't know what it's doing. Obviously, the larger the company, in theory, the more you can trust it. But then again, who knows? I mean, there was a bit of a hoo-ha recently where a huge tech company purchased a smart thermostat company. They had microphones in their thermostats which weren't actually being used, and that was the question of, are they tracking us? There's the thing recently where another large tech company that provides smart devices for the home has now using those smart devices to build an internet network all around your neighborhood that if you didn't know about, would be turned on by default. So even if you go for the big companies, which in theory should be more trustworthy, there's still questions around how much can you trust what they're doing them, especially if it's a company that makes money off mining your data. Honestly, the only way to defend against it is don't connect it to the cloud. There is, unfortunately, that's I know that's not the best answer because people want to connect to the cloud, but otherwise it's do a search, find out whether you can see any comments about the hardware, whether people have actually hacked it or not. There are professional hackers who will hack this stuff and try and find out where the problems are. And then, if you don't want them accessing anything else on your own network, think about setting up an isolated network. So, for example, my router, I can have multiple guest networks on there. So if I don't want an IoT device connecting to anything on my main network where my work computers, my personal devices are, I will connect it to my guest network. So that keeps it isolated. But yeah, unfortunately you just don't know. You just don't know how it's going to be. Don't plug it into the internet. It's the only safest way. Is there any insight on the percentage of people that create parented projects using Microsoft Cloud? No, I don't have those numbers, I'm afraid. And I don't even have those numbers. That's kind of privacy. We don't really know what devices you're using. It's not up to us to know this. I know a lot of students and hobbyists use Raspberry Pis. I think they're fantastic devices. We have great Python support for folks using Raspberry Pis to connect to the internet. We do have a lot of examples using Raspberry Pis. So I know a lot of folks do it. And I think they're fantastic devices, but we don't have that data. That's not the kind of thing we're interested in. Does Azure IoT Edge services provide ways of segmenting the AI workload to the IoT device and the edge? I don't know if it's got anything for doing automatic segmentation. Usually a lot of that will be built into your application code. So you can put what's called a gateway device. So you can actually have, say, all your IoT devices sending data to a gateway device, and that gateway could then make a decision as to what it does with the analytics. So you could have all your security cameras sending data to a gateway device, and that could then send that security camera footage onto a device locally, and then if it needs to send to the cloud, it could do that. So you could build your logic on the gateway for doing that. I don't know of any way automatically for automatic segmenting the workload. I know you can configure, you could do it via configuration. So you could say, these devices go, I'll push configuration that connects it to the edge device. These devices will push configuration to connect to the cloud, but nothing I know of that's automatic. What cloud services would an IoT device like Raspberry Pi be ideal for replacing? When you say what cloud services would it be ideal for replacing, what do you mean by that? Because the Raspberry Pi is just a computer. So you could replace anything in the cloud that could run on that computer. If you wanted home storage, for example, you could use your Raspberry Pi as home storage. Rather than store things in the cloud, you store Raspberry Pi. Obviously, you lose out on the backup and things like that. What cloud service would I do to migrate to a Pi? So again, it depends on what you're trying to do. So the Pi is not as powerful as the cloud, but the Pi can run IoT Edge, for example. So if you wanted to do video analytics, if you wanted to detect, I don't know, say faces using a security camera in your house, so when it detects someone's face, is this my friend? If they are, I want to unlock the door. You could run that on a Raspberry Pi. The Pi is powerful enough to kind of run that do facial recognition. I use the Pi as IoT devices. I use it to gather data and then take advantage of the cloud to do all the cloud processing. But I will run IoT Edge workloads on a Raspberry Pi. So if I want to run some AI work, for example, the one I do a lot of is image classification. So you can build an image classifier in the cloud, and I could run that in the cloud, but it runs quicker locally without me shipping data around on my Pi. So I would just deploy my image classifier from the cloud onto my Raspberry Pi. So, the moment I'm building a banana detector, to prove it, here is my banana that I've been using on a banana detector. And although I'm building that in the cloud using custom vision, I'm actually going to deploy it to my Raspberry Pi because I want to build a prototype device that I would use to distinguish between a ripe banana and an unripe banana. And if I do it on my Pi, it's faster. I'm shipping less data up to the cloud. So really, it depends. It's the answer of it depends. But your Pi, obviously, they are powerful for what they are, but they're not ridiculously powerful. So you can't run any hugely powerful workloads on them. Yeah, the 8 frames a second analytics I was getting on my Jetson Nano, for example, you won't get that on a Raspberry Pi. This you'd want to run on a Jetson Nano or up in the cloud. Cool. So thank you all for your kind comments. I'm glad you all had fun. As I say, reach out. I'm all over the internet, Jim Bob Bennett. Got any more questions, just reach out and I'll do my best to answer you. So yeah, thank you very much and enjoy your day.